So what's the difference between a data class and a regular class in Python? This is a note from myself to my future self. You have studied this. If you ever forget, just watch this video. Let's get started. Let's get into our shell. And let's just define a very simple regular class. Let's call it point. And we're using this point class to keep track of the x and y coordinates of points in a two-dimensional space. So let's define an init function, dunder init function, and or method, and let's just use that to initialize the attributes of our class. There's nothing strange here. If we want to define a point 1 here, we can just say point 1 and 2, and point 1 dot x would have been initialized and point 1 dot y would have been initialized. Now let's write the same class using data classes. Okay, now when we write a class using data classes, there is a reduction that happens in the boilerplate code that we need to write. For example, we don't need to write the dunder init method anymore. That function gets generated automatically. Let's see what happens here. So let's first import the decorator data class from module data classes, and let's use that to decorate a new class, call it DC point, and let's define the attributes here. So the difference here is we need to define the attributes. Let's call it x, and a type hint for the attribute. Let's say x of type integer and y of type integer. That's it. We didn't write the init dunder init method. So if we want to define a point using the data class, we can just say dc point 1 is equal to dc point 1 and 2. Similar to our point class, we can just say dc point 1 dot x is 1, dc point 1 dot y is 2. Okay, so the dunder init method got auto-generated. We didn't have to write that. What other functions get auto-generated? The repr function get auto-generated. So if we do point 1, this is how it's represented. And if we do dc point 1, you can see that it is a more refined way that the representation of this object is right now. So this is the job of the dunder repr method that also gets auto-generated when we use the data classes instead of regular Python classes. Now, there's one other dunder method function, and that's the equal dunder eq function that is used to basically compare two objects. We don't need to write that too. So if we have dc point 1 is equal to dc point 1 and 2, and dc point 2 again is dc point 1 and 2, and dc point 3 is equal to dc point 1 and 3. Okay, so two of these points are equal, one is not. So let's say dc point 1 is equal to dc point 2, and this is the dunder eq function, true, but dc point 1 is equal to dc point 3, dunder eq function is false. If we were to compare 2 points using our regular class, because this function hasn't been added to our class, then the comparison operation would not work as expected. So if we have point 1 and if we have point 2, 1 and 3, can we say point 1 is equal to point 2? We can say in this case 2, right? Let's call it like this. No, you see, it's not working properly. So although we can compare the two objects, but these objects are not equal because the dunder eq method is not functioning as expected. It's not comparing the x and y, which is technically what we are comparing when we say 0.1 equals to 0.2. What we want this to be returned true or false is if x is equal to x and y is equal to y. So, in summary, and this is not a general rule of thumb, but if we have a class that is keeping track of a set of attributes and the assignment of those attributes is straightforward, we can use an init function, and the comparison of those attributes is also straightforward. We can just compare them one by one and determine if two objects of that class are equal. We use a data class. It is a more summarized way of defining a class. Now, that's not to say that a data class does not have complex logic. It can have, but it normally is just a data container. It's just a place where we want to keep track of a set of attributes. There are some other elements or parameters that we can pass to our decorator to make the data class work a little bit differently. So when we define our data class, we can pass in the order is equal to 2 parameter in the decorator, and then define the point and define the x of type integer and y of type integer. Okay, so that's it, and we just said order is equal to true. By just specifying that, 4 additional dunder methods get generated automatically, and these are the lt, gt, lte, and gte. So these are the comparison operators, right? So if we have, for example, dc.1 is dc.1 and 2, and dc.2 is dc.1 and 2, and dc.3 is dc.1 and 3. Now, we had the dunder equal method before, so we can just say dc.1 is equal dc.2. That's true, but for 3 it's not true. So this comes with the regular data class decoration without specifying the order, but now that we have the order is equal to true, we can just do comparison like greater than, and this should return false. But if we say dc.1 is less than dc.3, that's a true statement. It's because it's comparing x with x and y with y. So that is how it's determining that these 2 points are equal. So that's pretty cool. We didn't have to write any of those. So again, just repeat that. A data class is a data class. The name is telling you something. It's where you're keeping track of a bunch of data, and you don't want to spend time writing a lot of the dunder functions, and those get generated for you automatically. There is another keyword here, and that is the frozen keyword. Frozen is equal to true, and that is to make an instance of this class immutable. Okay, so if we define the class like this, let's define an instance like this, and let's just say dc.3 dot x is equal to 5, and you can see that it's a frozen instance error. It's kind of like a tuple now, right? Where you define a tuple, it's an immutable object, and you cannot change an element of that. So it gives you immutability for the attributes that are defined in your class. If you don't specify that, it just works like regular Python classes, you can change the attributes as you wish. So what else do we have to cover here? So we talked about the ordering, we talked about the mutability, and we talked about the use cases, where to use the data class versus a regular Python class. You can specify default values for the attributes, so you can just initialize x and y to 0. So you can just say dc point 4 is equal to dc point, and dc point 4 dot x is 0. So that is just specifying a default value. And let's take a look here, going through my notes. Oh, if you want to exclude a field from comparison, how do you do that? Let's say we have an item that has a name and a price. When we compare elements of that item, A and B, we want the name to be compared, not the price. So let's write that. So let's just bring in from the data class import field, and let's use our data class decorator to create a class called items, or inventory item, or what have you. Let's define an attribute name of type string and price of type float, and this field compare is equal to false. Okay, so if we have a item book and the price is $10, and we have B of item and this is book and the price is now $15, and if we compare A to B, it's still true because we have excluded the price from the comparison, and it's just comparing the name field. So that's another thing. Ordering, we talked about the dunder methods that get added when we define the order is equal to true. In the definition of the data class are the dunder lt, dunder le, dunder gt, dunder ge. If we want to enable ordering in a regular Python class, we need to specify these in the class definition, or else we'd get we get an inconsistent result when we compare two instances of the class. We talked about frozen, and yeah, I think that's it. So use data classes whenever you want to keep track of a set of attributes, and just that, and use regular classes if you have attributes and if you have a more complex logic that needs to operate on those attributes. So that is it. Thank you for watching, and see you in the next one.